So let's go ahead and now prove that the square root of 2 is irrational. So here I'm going to use my proof by contradiction. So in search of a contradiction, because I'm lazy and I don't have a lot of space, I'm going to abbreviate that. In search of a contradiction, assume not P, not the statement I'm trying to prove. So assume that the square root of 2 is not irrational. So in other words, assume that it's rational. So we're going to assume that there exists a and b such that we could write square root of 2 as its ratio. And in addition, we are going to assume that there are no common factors between a and b. And it's actually a side note, this is a definition. So our definition here is that a rational number a over b is in reduced form if the numerator and the denominator do not share any common factors. And it's pretty easy to show that any rational number can be reduced or represented in reduced form. So for example, if you had this rational number, 4 over 8, it is not in reduced form because both the numerator and the denominator share a common factor. In particular, they share a common factor of 2. So this thing is the same thing as 2 over 4. That's also not in reduced form because our numerator and denominator share a common factor. So factoring out a 2, I end up with 1/2. Now it's in reduced form. And that's basically how you would prove that every rational number is in reduced form. You just keep factoring things out and canceling them until you can't anymore. So it's okay to assume that there are no common factors between a and b in our proof, because we know that that's already the case. So we have square root of 2 being a rational number. So the first thing that I'm going to try doing is let's go ahead and just square both sides. If we square both sides, we get 2 equals a squared over b squared. And if I rearrange this just a little bit, what I'm going to get is that (2b squared equals a squared. Well, a squared equals 2 times some other integer. That means it's even. And in a lot of the previous examples that we have seen, we know a lot about even numbers. So recall that just a few videos ago, we proved n squared is even if and only if n is even. So here's a particular number, its square is even. So that implies that a would have to be even, right? I'm using this direction. If the square is even, then the number itself is even. So the square is even. So that means that a is even. Well, how does that help us? Well, a is even, and we had represented square root of 2 in reduced form. So that tells us that b cannot be even. Because b, if it was even, that means it would have a factor of 2, and I would have an even number over an even number. I could factor out a 2 just like I did over here, and it would not be in reduced form. So it can't be even because otherwise it would not be in reduced form. They would share a common factor, the numerator and denominator, of 2 if they were both even. So that means, well, if it's not even, that means it's odd. So let's go ahead and use this to then try to derive some sort of contradiction, because we're using the proof by contradiction proof technique. Well, I know A is even, so since A is even, that means there exists some C such that A equals 2C. So if A equals 2C, because it's even, I can take this expression that I have and plug in 2C wherever I see my A. So plugging in that particular equation right there, what I end up with is 2b squared, and then I substitute 2c in for a, and I square that. Now let's go ahead and simplify this around a bit. (2b squared) equals 4c squared. Well, I can simplify this because I see a 2 on both sides. Haha. So b squared equals 2c. 2 times another number. That means b squared is even. But we already know that if b squared is even, that implies that b is even. Relying on this previous fact that we proved. And so do you see the contradiction that we have? Our contradiction is here we have b is even, and here we have b cannot be even. That is our contradiction. That's a statement that can never be true. They can't mutually coexist. B can't be both even and not even. This is our contradiction. So therefore, we have derived our contradiction, and we can conclude that our original statement is true. And I have finished. So recapping, with my proof by contradiction, I assumed that square root of 2 was rational. And then, by using some manipulation, and importantly, relying on some previous facts that I have proved, I was able to derive my contradiction. In fact, in most proofs by contradiction, you will be relying on things that you have proved in the past. We use this fact that n squared being even implies n even. We use that twice here. We used it right up here, and we also used it right here. And that was the key to being able to derive our contradiction. So, square root of 2, that is irrational. So as I said in the previous video, you can't represent it using floating point numbers, and I have proved that right here.